Hello everyone. Yesterday we have seen three different techniques, that is three different distribution that comes under continuous distribution. Today we'll see some other. The first one is Erlang distribution. Here this Erlang distribution is a two parameter family of continuous probability distribution. What are those two parameters? First one is a positive integer k. This one will be called as a shape parameter, and a positive real number lambda. Then this will be called as the rate. Okay, this was developed by A.K. Erlang to examine the number of telephone calls which might be made at the same time to the operators. Okay, why we have just taken this Erlang distribution means here we can just have an example of waiting times in queuing system. See, for example, if only one system is present, only one system, but for that one system, so many customers will be coming to take the service. In the same way here, only one telephone operator is there. For that telephone operator, number of calls is coming. That is being used in this queuing system. So only we have just taken this Erlang distribution, because here we are dealing with the input models in the queuing system. Always here we will just deal with this technique only. So we have taken this Erlang distribution over here. The Erlang distribution with shape parameter, that is I have already told shape parameter is k. Okay, shape parameter k is equals to 1 simplifies to the exponential distribution. For example, if you take k is equals to 1, then it will be simplified to exponential distribution. In the last video, we have seen the exponential distribution. So it is f of xj is equals to beta theta e power minus beta theta x. Okay, beta is the shape parameter and theta is the scale parameter. And here mean is given as e of x is equals to e of x1, x2, x3 till e of lambda k. So this can be given as k number of times 1 divided by k theta. So it is 1 divided by theta. In the same way, variance, it is v of x, v of x1, x2 till v of lambda k, that is 1 divided by k theta square. This is mean and variance for Erlang distribution. Here the thing is, you have to remember only this formula. If k is equals to 1, then it simplifies to exponential distribution. It is given by beta theta e power minus beta theta x. This is simple Erlang distribution. Now we'll go for the main important thing, that is normal distribution. Okay, here a random variable x has the normal distribution with mean mu and variance sigma square. Here variance we always take as sigma square. If it's given by the PDF, that is probability density function, f of x is equals to 1 divided by sigma square root of 2 pi e power minus 1 by 2 x minus mu by sigma whole square, and it varies from minus infinity to infinity. Okay, and this is the notation we use to identify this normal distribution. So x and the symbol denotes is a normally distributed, This is the symbol used for normal distribution. X means the random variable. The random variable x is normally distributed to n. Okay, is normally distributed with mean mu and variance sigma square. N means the number of variables. Okay, x is normally distributed with mean, mu and variance sigma square. And we'll see the special properties of normal distribution. What are the special properties of normal distribution? Already I have told you this Erlang distribution will vary from infinity to minus infinity. Even this also will vary from minus infinity to infinity. If limit extends to minus infinity, f of x is equals to 0. And if limit extends to infinity also, f of x is equals to 0. The value of f of x approaches to 0 as x tends to be infinity. Always it may be, whether it may be positive value or negative value. If x tends to infinity, always the f of x, that is normal distribution, tends to 0 only. Okay, that is, it is independent of the symbols, whether it may be positive or negative. Next, second property, it is very important. F of mu means the properties are very important. F of mu minus x is equals to f of mu plus x. PDF is symmetric about mu. I have already told, whether it may be positive, negative or positive, it tends to 0. Even here also it is symmetric. It is negative also the same thing, it is positive also the same thing. f of mu minus x is equal to f of mu plus x. Then maximum value of your probability density function occurs at x is equals to mu. Okay, x is equals to mu. That is, x will be always equal to mu. Then the CDF will be given as f of x is equals to p x less than equal to x. It tends to minus infinity to x 1 divided by sigma 2 pi e power minus 1 by 2 x minus mu divided by sigma whole square dt. And you must know how we have calculated the CDF, is it not? Here the transformation variables we have taken as z is this z will be considered as the transformation function. We are deriving the CDF by using transformation function. This is the transformation function, that is t of mu divided by sigma, which allows the evaluation to be independent of mu and sigma. We can just take out this mu and sigma from this equation by using the transformation formula. If x is normally distributed with mu and sigma square, then z is equals to x minus mu by sigma, because here we are dealing with x instead of t. I'm just taking x over here. Then what you will get, f of x is equals to p of x less than equal to x, then p of z less than equal to x minus mu divided by sigma. I'll take this as a limit now. Instead of x, I'll take this as a limit minus infinity to x mu power sigma, because I'm taking which is less than equal to x. So this will remain as it is, 1 divided by 2 pi, which is independent of mu and sigma. So I'm not taking this sigma, divided by 2 pi e power minus, this will be considered as z. So I am taking z square. See here, z is equals to x minus mu sigma divided by sigma. So this one I will replace with z. Z square divided by 2. So minus z square divided by 2 dz. I am using z, so I am taking dz over here. Okay, and this can be just replaced by phi of z dz. This entire thing 1 divided by square root of 2 pi e power minus z square divided by 2. I'll take this entire thing as phi of z dz, where f of x is equals to phi of x minus mu divided by sigma. Okay, then if I do this one PDF, simply the PDF is given by dou z, that is phi of z is equals to 1 divided by 2 pi e power minus z square by 2. It z tends to minus infinity to infinity, and CDF is given by the value of t. Phi z is equals to minus infinity to z 1 divided by 2 pi e power minus t square by 2 dt. This is how we'll just calculate this one by using the transformation formula. Now we'll see the problem on this one. Given x is normally distributed with mu, that is mean 50 and variance 9. Compute f of 56. If it is normally distributed, then you have to compute f of 56. Then I'll go for the solution. F of x is equals to p of x less than equal to x, that is phi of x minus mu sigma. F of x formula just now we have discussed, is it not? See, this is f of x. You have to find out f of 56, so I am taking this one. F of x is equals to phi of x minus mu divided by sigma. In the question itself they have given you have to find out f of 6, so I am taking this formula. F of 56, what is the value of x? It is 56. Okay, and here mu value is 50 because it is x is normally distributed to mu comma sigma square, is it not? This is the representation of your normal distribution. So here divided by sigma, here sigma is there, here sigma square is there. Sigma square means 9, 3 square is your 9, so I'll take 3 over here. Okay, sigma square is equals to 9, so sigma is equals to square root of 9, so sigma is equals to 3. I'm taking sigma value as 3. 56 minus 50 is 6. 6 divided by 3 is 2. Phi of 2. Now you know the value of phi of z, is it not? So here this is the value of phi of z. 1 divided by 2 pi e power minus t whole square divided by 2. This one CDF, because f of x always tends to the continuous distribution function, not for the PDF. So minus infinity to z, 1 divided by 2 pi e power minus t square by 2. That one you have to take. So 1 divided infinity, this is x, in place of x 2 is there, so it will tends to 2, sorry, z, in place of z 2 is there, so it tends to 2. Minus infinity to 2, 1 divided by square root of 2 pi into e power t minus t square divided by 2. You have to just integrate this one. Okay, if you integrate, you will get this value. This one I'll consider as the constant, will keep out. Only e power minus t square by 2 you have to integrate. Okay, then you will get the value 0.63662, that is, it will become square root of 2 by pi, then minus 0.0185185. If you just equate this one, e power infinity is 1 always, then e power minus 8 by 2, that is e power minus 4 you will get. E power minus 4 value is this one. You will get 0.8 for this one, 0.08, and then you will get the value 0.72 for this. This is about your normal distribution. The formula for means the problem for normal distribution. And next we'll go for Weibull distribution. This is, all these things are very simple, just the formula, no derivation or nothing, just the formula you have to remember. A random variable x as a Weibull distribution of its PDF, that is probability density function, has a form f of x is equals to b divided by alpha, okay, x minus v by alpha whole power e power minus 1 beta minus 1, then exponential of minus x minus v by alpha whole power beta, where x is greater than or equal to v. Here v is the location parameter. As you all know, beta is the scale parameter and alpha is the shape parameter. If you take v is equals to 0 and beta is equals to 1 for this PDF, okay, we are just simplifying it. Take v is equals to 0, v is equals to 0 and beta is equals to 1. Then what you will get, f of x is equals to, see, beta is 1, so 1 divided by alpha, then this is 0. So e power minus x divided by alpha. Here it is 0. Okay. Here it is beta is 1. 1 minus 1 is 0. This whole power 0 you will get it as 1. So here you will get only 1 by alpha. Then in this exponential function, exponential of x minus v by alpha, x minus v is x minus 0 whole power 1. So you will get x by alpha. So I am writing it as e power minus x by alpha. That's it. This entire term will become 1 because it will be whole power x by alpha whole power 0. This will be equal to 1. Here exponential x by alpha you will get minus x by alpha, where x greater than or equal to 0 because v value is 0 otherwise. This is the simplified formula for your Weibull distribution. 1 by alpha e power minus x divided by alpha. This is the Weibull distribution. Next we'll go for one more distribution, that is triangular distribution. What is this triangular distribution? A random variable x has a triangular distribution if its PDF is given by 2 into x minus a divided by b minus a into c minus a. Because here why I am taking 3 values over here means, if you have a triangle, then you should minimum you will be having 3 values, a, b and then c. But here we are taking only 2 values. Is it not? That is just a distribution. But here it is triangular. Triangle means minimum you will have 3 nodes, a, b, c. So you have to take, is a less than equal to x less than equal to b, b less than equal to x less than equal to c, then otherwise it is 0. 2 into c minus x divided by c minus b into c minus b. Sorry, c minus a into c minus b. Okay, so here your e of x, that is mean, is given by a plus b plus c divided by 3. We have 3 divided by 3 mean. Then mod b means if you have to calculate for b, then how you will calculate? 3 into e of x minus a plus c. This is the PDF means the diagrammatical representation of your triangular distribution. This is a, This is B and this is C. This is A and C. This height of B is 2 divided by C minus A. See here, why I am taking this as 2 divided by C minus A? It is equivalent two parts, then it is 2 divided by C minus A. This is your triangular distribution. We'll go for the last method of this continuous distribution, that is log normal distribution. What is this log normal distribution? A random variable x as a log normal distribution if its PDF is given by 1 divided by square root of 2 pi sigma power x. Exponential of ln, log normal distribution, you should have ln for x. ln minus mu square divided by 2 sigma square. Here also mu is mean, sigma is the variance. Okay, where sigma square is greater than 0, where sigma square is greater than 0, then e of x is equals to e power mu plus sigma square by 2. Variance v of x is equals to e power 2 mu plus sigma square, e power sigma square minus 1. This is the mean and variance which is given. Always your sigma square should be greater than 0, because if it is 0, then this entire thing will become 0. You should not have a value divided by 0. It is an error, is it not? So always the sigma square should be greater than 0. It should not be greater than or equal. It should be greater than 0. Okay, here nothing to just compress this one. So I'll just write it as it is, because only we are using the mu mean and the variance. That's it. We are not using any other attributes over here. So this is the standard log normal PDF, that is probability density function, and this is the mean and this is the variance. Okay, for this one we'll be done with continuous distribution functions, and we have a last topic in this one, that is Poisson process, that I'll just explain you in the next video. Thank you.